Today we talk about how to calculate bond energy and bond length for a compound. We will illustrate the ionic bond between the sodium cation and the fluorine anion in sodium fluoride as an example. The interaction between the sodium cation and the fluorine anion can usually be modeled by one repulsive potential plus one attractive potential. To make it clear, we here use the red color to mark the attractive potential and the yellow color to mark the repulsive potential. As you can see, the attractive potential, minus A divided by R, is negative, which increases slowly with the interatomic distance R. The repulsive potential, B divided by R to the nth, is positive, which decreases rapidly with the interatomic distance. The interatomic distance R is the only variable here, and there are three parameters, A, B and N, which changes with the atom species. This kind of potential can be visualized in such a way. We can see that there is a minimum energy point, where the attractive force and the repulsive force balance each other. At infinity, the potential energy goes to zero. Therefore, the minimum energy is just the bond energy, which physically means the amount of energy that is needed to separate the two particles from its balanced distance to infinity. The interatomic distance corresponding to this minimum energy is then the bond length, which we denote as R none. To obtain the bond energy E bond and the bond length R none, we will need to find the minimum point in this energy curve by setting the derivative to be zero. The derivative of E with respect to R is a divided by R squared minus NB divided by R to the n plus 1 order. Physically, the opposite of the energy derivative gives us the force exerted by this potential energy. To find the minimum energy point is equal to find the zero force point, so we set the force equal to zero, in order to find R none and E bond. By solving this zero force condition, we can find a general expression for the bond length R none, which is the n-1 root of NB divided by A. Put this value of R none into our original formula of energy, we can get the value of the minimum energy point, namely, the bond energy E bond. Now we plug in the parameters for sodium fluoride, where A equals to 1.0812, B equals to 2.27510 to the minus 7, and N equals to NaF. Ultimately, we can obtain that the bond length of sodium fluoride is 0.1926 nanometer, and the bond energy is minus 4.99 eV. Thank you for learning. Subscribe and like if needed.